Hey guys, it's the Math Maniac here, and today I'm going to be talking about science, not math. So from now on, I'm going to be doing both science and math videos. Some are going to be like both science and math. So for this video, I'm going to talk about the scientific method. So if you've ever seen every major discovery in the world, like for example, special and general relativity or Newton's laws of gravity, you can see that usually the people who made them had a very extensive and laborious job of doing experiments, restarting those experiments, and usually making a lot more experiments. So this is and what they did was called the scientific method. It's a method of experimentation which helps you come to a conclusion in which you can share your results with others. So let me go through the basics of this. So first, you can have a science related question. You should have a science related question, and for example, let me say, why does why does ice cream melt on a hot day? That's a very basic one. So and then you have to create a hypothesis based on your question. And a hypothesis is kind of like a educated guess, or like for example a inference. Like in English, you in grammar you'd call it an inference. So I could say, I think that ice cream melts on a hot day because the radiation from the sun is hitting the ice cream and causing it to melt because there's the temperature change in the ice cream. Next one, you should perform an experiment. First, before that, you should do some background research, and then you should perform an experiment. So what mean by that is like background research, like you should see if any other scientists have done something similar to you and what the results are. So, and then you should perform an experiment, which means taking your ice cream, keeping it on a hot day, and seeing why you think it melts, and seeing like putting different variables and using that. So, the most common mistake here is not using the same variables. Like, so in this I have three different variables. I have the heat, I have the heat of the sun at the moment. I have the type of ice cream, and I have the temperature of the ice cream. So if those three, if two, so you want to know how much it melts. So you have to keep the heat and the type of ice cream the same. I mean, the heat, the type of ice cream, and the coldness of the ice cream the same, and you should see why it happens. And you should see if like you should see the heat, and you should see how long it takes to melt it. The next thing is to analyze your data and compare it with your hypothesis. Okay, so I found out that ice cream melts because of the heat. If that supports your hypothesis, good. And then we go to 6B right here. If it's right, you share your results with other people and find another science related question you have. If it's not right, that's okay, because that's really what learning is. So what you do is then you repeat from step 3, and you keep on repeating. That is how many scientists have actually got successful. So now let me show you the second part of this video. I'm going to talk about common errors in the collection of data, because this is also related to the scientific method. So first thing is a systematic error. So systematic errors is where when you use a tool incorrectly, and then you get incorrect results because of that. For example, let's say if I did not measure, if I had a liquid in a container, and I found the mass of that liquid, but I found the mass incorrectly because I did not subtract the mass of the liquid from, I did not subtract the mass of the container from the mass of the liquid to find out that the actual liquid mass. So the second one is random errors. So random errors are when you have a if it's because of the measuring tool itself. It's not your fault. You operate correctly, but it's because of the measuring tool itself. For example, let's say I have a triple beam balance, but the thing is one side is heavier than the other, always been heavier than the others. If I use that, it'll give me a incorrect value. So that's going to be a random error. And the third one is a parallax error. So a parallax error is when a person if you misread something because of the perspective that you're looking at something. So, like for example, if you're looking at a meniscus, if you're looking at a meniscus, which is like the bottom of a water, if you keep water, it actually makes like a U shape, parabola shape. So you have to look at the bottom of that. So if you look at the bottom from like a angle, it looks a lot more different than if you look at it from like straight. So that is a parallax error. So that it's just an error caused by perspective. Thank you guys for watching this video. I hope you learned a lot about from it. And if you have any if you have any comments, please type them below so that you can I can teach some more science topics. Thanks, guys. Bye.